Here are two more examples on how to determine if I have a vertical asymptote or a hole in the rational function. Remember when we were trying to find out where the vertical asymptotes are, I would take my denominator and set that equal to 0. So let's do that. I have 0 is equal to my denominator. 0 equal to x squared minus 3x plus 2, and then I solve for x. The x I get, those x's are the x's that make this function undefined. So those values on the graph will become either holes, which are undefined points, or they'll become vertical asymptotes, which are also undefined. It's like a wall. The wall won't let you get near that value because it'll produce an undefined rational function. So whenever we have quadratic functions like these, all you have to do to solve them is either use factoring or the quadratic formula. Lucky for us, this denominator factors out very nicely. X and x, you look for the factors of 2 that will add or subtract to 3. That means 2 times 1 will add to 3, so I'll use 2 and 1. And then since this is positive and this one's negative, the only way I'll get a negative 3 here is if I add 2 and 1, but they both have to be negative to get a negative 3. And negative times negative will give me positive 2. So that's how you factor. And now I solve for each of these x's using the zero product property, which tells me if this times this is 0, then this has to be 0 or this one has to be 0. And that's how we solve for our x. X minus 2 equals 0, x equals 2. X minus 1 equals 0, x equals 1. So these two x's that I found are my possible vertical asymptotes. How do I find out for sure if it is or not? Well, I have to take each one of them and substitute it in the numerator. Now, there's some rules here. If I substitute an x that I think is a vertical asymptote in the numerator, and I get a 0 in the numerator also, then that means I have to study this further. If I substitute my x in the numerator and I do not get a 0, then you've hit the jackpot. This is a vertical asymptote, okay? The same goes for this one. You substitute it in the numerator, check. If you get 0, we need to go a step further. If you do not get 0, you're done. You can say this is a vertical asymptote. Okay, so let's check. X equals 2. X equals 2. I'm going to plug it in the numerator. And that gives me 2 squared, which is 4. And 3 times 2 is 6. So 4 plus 6 is 10, and 10 minus 4 is 6. That means that this x equal to is a vertical asymptote because I did not get 0 in the numerator. This is a vertical asymptote. Now I'm going to check x equal to 1. If I plug in x equal to 1 in the numerator, I get 1 squared. 1 squared is 1 plus 3 times 1, which is 3. So I have 1 plus 3 is 4. And 4 minus 4, that gives me a 0. So this x equals to 1 will give me a 0 value in the numerator if I plug it in here, and it will also give me a 0 value in the denominator. When that happens, that's when I need to study it further and determine, well, could this be a vertical asymptote or could it be a hole? And we saw on our last video that we determined that by comparing the multiplicities of the 0 in question. Okay? So to do that, I need to factor this expression. I need to factor the numerator and the denominator, which we already did, right? We already factored the denominator and we said this would be x minus 2 times x minus 1, and the numerator would be x plus 4 and x minus 1. And when we factor this, it's easy to see that this part of the function, this part, is where I need to look to see the multiplicity, because this is the x that's in question here, not any of these. So I'm going to concentrate on these two, okay? They're the same. I could cancel these out. Be careful if you do that. If you do that, make sure to write that x cannot be equal to 1. I like to leave it there because that way I don't forget about them, okay? We're going to do an example where we can just cancel them out and you get the same thing, okay? But for now, let's just leave it as it is. So I have this 0 in the numerator and this one in the denominator. They are the same. If I plug in x equal to 1, you can see easily 1 minus 1 is 0, and 0 times that in the numerator will give me 0. And this one is also 0 times that is going to be 0. So I get 0 over 0. The rule says that if the multiplicity of the 0 in the numerator is greater than or equal to the multiplicity of the 0 in the denominator, then I'll have a whole. So in this case, x minus 1 in the numerator has multiplicity 1. 1 because it's only repeating itself once. And in the denominator, I have a multiplicity of 1 also. So in this case, the multiplicities are equal. That tells me that I will have a whole. So for my answer here, I know I'll have a vertical asymptote at x equal 2, and I'll have a whole. This is a whole, not a vertical asymptote. Okay? Now, where is the whole? The whole is somewhere at 1 somewhere on my coordinate plane. Okay? Where could that be? Well, the way to find that is I'm going to, since I need a little bit more space here, I'm going to erase this function as my second example, and I think we'll cover it. We'll cover that other example in another video. So how do I find the y value of this coordinate where my whole is? Well, what you do is I can rewrite this function as x plus 4 over x minus 2. Because since these two are the same factor, I can cancel these, okay? But if I do that, I have to make sure and establish here that x cannot be 1, okay? This doesn't disappear. It does, but I have to make sure to say, look, x can't be 1, okay? I've canceled it out, so you can't see that anymore, that x can't be 1, but I write it next to it so that people know that this function has a limitation. X can't be 1, okay? Now, what does this mean? This means that this original function, if I were to graph this original function, and if I were to graph this function here, they would look exactly the same, except at the value x equal 1, somewhere on the x-axis, at 1, I'll have a whole. That's the difference between this graph and this graph. But it will have exactly the same curve. The same curve, except it'll have a whole at 1, okay? But I don't know where exactly on the coordinate plane. So this is what we do. If I know the whole is at 1, I'm going to use this function, this simplified function after canceling these two factors out. And I plug in, I have f of x is equal to x plus 4, x minus 2, and I evaluate the function for the whole. This is the whole. The whole is at 1. So I evaluate for that value, and I'll have 1 plus 4 over 1 minus 2, and that's 5 over negative 1, which is negative 5. So now I know exactly where the whole is. Okay? And there you have it. This function, when we sketch this graph later on, this is not going to be on your quiz for this week. I already know I'll have at the value of x equal to 2, I will have a vertical asymptote at 2, and I will have a hole at 1, -5, somewhere down here. I will have a hole in the graph, okay? And it makes sense because these values will make my function undefined. So it's either a hole or a vertical asymptote, which are values the graph does not touch or cross, okay? I hope you understood this example. I'm going to do the other one on another video, and I hope this puts it all together for you. And then after that, we'll make a video on horizontal asymptotes. I'll see you then.